Okay, well, just a little helicopter view of extreme events and how they may be changing due to the enhanced greenhouse effect, due to global warming. To start with, we've seen a warming trend over Australia of about a degree over the last 100, particularly over the last 50 years. And we've seen an increase in the frequency of extremely hot days, so there's been an increase in heat wave conditions over that time. And also a decrease in the frequency of frost generally. Now, we expect more of that trend as we go forward into the future. We expect Australian region warmings of a half up to 1.5 degrees in the next 20 years, and perhaps warming of 1.5 up to 5 degrees by later in the century. So the warming is likely to accelerate a little bit over what we've seen in the past, and that means the increase in frequency of hot days that we've seen recently is likely to continue and probably get worse. The other sorts of extreme events that are potentially going to be changing, or have been changing, include extreme rainfall events. If everything's right for a heavy rainfall event, a warmer atmosphere can hold more moisture, so the intensity of heavy rainfall events can increase. In the Australian context, though, we're also seeing a tendency for overall a decrease in rainfall. And so the combination there is one of an increase in drought conditions, but when everything's right for a heavy rainfall event, that's more intense, so therefore the potential for increases in flooding as well. Other aspects of extreme weather, and potentially in the Australian region, there's concern over tropical cyclones and how they may respond to global warming. There haven't been any clearly identifiable trends in the Australian region in the past. What our climate models say about what the future might hold fairly consistently say that tropical cyclones are likely to become more intense. However, there may actually be fewer of them, so there's some tendency for fewer tropical cyclones but more intense storms. So what you could say is that as we go forward over the next few decades, greater likelihood that if you're having a tropical cyclone it'll be in the more intense categories, but perhaps some longer periods in between where we don't see any. There isn't any evidence that they're shifting further south at the moment. However, our climate models do indicate some southward shift as a possibility in the future. Not a really dramatic one, perhaps going a few degrees of latitude further south before they stop being tropical cyclones. But that's an indication of our climate models. That's not something we've seen in the real world yet. The climate models are large mathematical representations of the climate system built around the laws of physics. They're actually very similar systems to what we use for weather forecasting, but we don't actually need to feed in current weather conditions to run climate simulations, because we can do a good simulation of the climate system just by specifying the size of the Earth, how fast it's spinning, what the atmosphere is made of, and we can actually build up a good climate simulation from the laws of physics. And we can run those climate models for 100 years, and although they generate weather in them, we average those and get the trends in climate that the models are simulating. And the models are able to simulate the warming that we've seen over the 20th century, over the last 100 years, quite well. They don't simulate the actual sequence of day-to-day weather events, though. And they simulate further warming to go forward into the future. What you have to realise that with extreme events, they're very variable in their occurrence. Like you might get a few tropical cyclones one year, none the next year, then quite a few the year after that in a region. Goes up and down a lot from year to year. But what we've got going on here is a lot of year-to-year variability, but at the same time, underlying that, probably a long-term trend. Right at the moment, it's too early to be able to pick out at least in the Australian region, to pick out the trends, the long-term trends that are driven by human influence amidst the fairly big year-to-year variability that we have. So it might still be a few decades before the forced changes in tropical cyclone behaviour starts to become really evident compared to those natural fluctuations. Well, what the models are suggesting is that as we go forward in time, and again, look, we're projecting, a decade or 2 or 3 decades into the future here. So it's not something that, necessarily applies right this coming summer, of course. Due to increases in temperature, and due to decreases in relative humidity and decreases in rainfall, which means that the environment becomes drier, the models are indicating quite strong increases in fire danger. Now, the models are not showing a particularly strong change in the occurrence of extreme winds in some of those fire-prone areas of southern Australia, but the other factors that are important, such as higher temperatures and lower relative humidity, the models are indicating a trend towards conditions there which are more extreme. The change in climate might, over time, set up conditions so that when very windy conditions come, those conditions end up being more intense than what they have been in the past. Look, it's very difficult to make predictions about what's going to happen in just the next few years. We can make seasonal predictions about trends looking forward a few months based on climate science. We can also have something to say about long-term trends due to global warming. Saying precisely what's going to happen looking forward to, say, the next 10 years is probably the area we have the greatest difficulty in making predictions.